All right, so today we are diving into Docker.
Ooh, Docker.
It's one of those things you hear about all the time,
Yeah, it's everywhere.
but it can be kind of tough to wrap your head around, like, what is it really and why should I even care?
Right, it's like this mysterious, powerful tool, but what's all the hype about?
Exactly. So that's what we're going to try to figure out today. We've got this awesome beginner's guide to Docker by Prakar Srivastava,
Oh yeah, his guide is great.
and we're going to break it down, pull out the key insights, and hopefully by the end of this, we'll all have a much better understanding of what Docker is all about.
Sounds good to me.
So the guide starts by describing Docker as a tool for building, running, and distributing applications in these things called containers.
Containers, yeah, they're like little self-contained boxes for your apps, which is super efficient, makes them really easy to move around.
Okay, so containers, I get that part, but how's that different from a virtual machine? I mean, aren't they both kind of isolating your app in a way?
That's a good question. Virtual machines, they run your app inside a whole separate guest operating system, which sits on top of your computer's main operating system.
So you're basically running a whole extra computer just for one program.
Pretty much, yeah. And it's really resource intensive.
And slow.
Yeah, exactly.
That seems a little overkill.
It is. Containers, on the other hand, they're way lighter.
Oh,
They
okay.
use the host operating system's own mechanics for isolation, so you get the benefits without all the extra baggage.
Gotcha. So it's like they're more streamlined.
Yeah, exactly. And that's one of the big reasons why Docker is so popular. I mean, even companies like Google's are using it to optimize their resources.
Really? Google uses Docker?
Yeah, they do. The guide even mentions that Google was able to get rid of a whole data center thanks to containers.
Whoa, hold on a minute. You're saying they got rid of an entire data center?
Yep, that's the power of containers.
That's insane. How did containers even make that possible?
Basically, by switching to containers, Google was able to squeeze way more performance out of their existing hardware.
So they didn't even need a whole separate data center anymore.
Nope. Containers made them that much more efficient.
That's incredible. So we've got portability, we've got efficiency, even cost savings. This all sounds amazing. What's the catch? There's got to be a downside, right?
Well, there's always a learning curve with any new technology, right? You need to understand the core concepts and terminology.
Makes sense.
But this guide does a really good job of breaking it down.
Okay, good.
For example, it explains the difference between Docker images and containers.
Okay, so remind me again, what's an image?
An image is basically like a blueprint for your container.
So it's like the instructions for building the app.
Exactly. And then the container is the actual running instance of your app.
Okay, so the image is the blueprint and the container is the actual house.
Exactly. A perfect analogy.
Okay, that makes sense. So if the image is the blueprint, what actually builds the container from that blueprint?
That's where the Docker daemon comes in. It's this process that runs in the background of your operating system, and it manages all the containers. And you interact with the daemon using the Docker client, which is a command line tool.
So it's like giving instructions to a builder who then constructs the actual container based on your blueprint.
Yep, you got it.
Okay, cool. What about Docker Hub? What is that and where does that fit into all of this?
Docker Hub is like this massive library of pre-built Docker images.
So it's like a giant app store for Docker images.
Pretty much, yeah. It's where you can find and share images for all sorts of applications, so you don't have to create everything from scratch.
So you can just pull down an image, modify it, and even push your own custom images to Docker Hub.
Yeah, exactly. It's a really great resource.
That's pretty awesome. Actually, the guide walks us through deploying a simple web server using a pre-built image from Docker Hub.
Oh, that's a good one. It highlights some really useful commands like Docker run to start a container, Docker torps to list running containers, and Docker arm to remove them.
Oh yeah, I've seen those commands before.
Yeah, and it introduces these flags like -D for running a container in detached mode.
Detached.
Yeah, it means you can close your terminal and the container will keep running in the background.
Oh, that's really handy.
Yeah, it is.
Okay, so we've seen how to use pre-built images, but what if I want to create my own Docker image for like a custom application?
That's where Docker files come in. They're essentially text files with instructions that tell Docker how to build your image. Think of them like recipes for your containers.
Okay, interesting. So what kind of ingredients go into these recipes?
Well, the guide uses this fun example to demonstrate it. It's a Flask app that displays random cat GIFs.
Cat GIFs. Everyone loves cat GIFs.
Exactly. And it even links to the source code on GitHub so you can follow along.
All right, I'm in. So how do we actually build this cat GIF app into a Docker image?
We create a Docker file and use commands like from to specify the base image we're building upon coffee, to add our app code, and run to execute commands during the build process.
Like installing dependencies?
Exactly. We also use expose to tell Docker which port our app will be using,
Okay.
and cmd to define the command that runs when the container starts.
So we're basically defining the entire environment for our app within this Docker file?
Yep, that's the idea.
And once we have the Docker file, we can use the Docker build command to create the image.
Exactly.
Okay, and then what?
Once the image is built, we can use Docker run to launch a container based on that image. But then to take it a step further, the guide shows how to deploy this cat GIF app to AWS using Elastic Beanstalk.
AWS, I know it's a popular cloud platform, but how does it fit into the Docker world?
Elastic Beanstalk, or EB for short, is a service that makes it really easy to deploy and manage applications on AWS.
So it's like a personal assistant for your app in the cloud.
Pretty much, yeah. We first need to push our cat GIF image to Docker Hub so it's accessible from AWS.
Got it. So Docker Hub acts as our image repository.
Exactly.
And once the image is on Docker Hub, how do we tell Elastic Beanstalk to use it?
We use this special file called dockerrun.oz.json.
Okay.
It's basically a set of instructions for Elastic Beanstalk, telling it which image to use, what ports to open, and other important details.
Okay, so then with a few clicks in the AWS console, we can deploy our app and have it running in the cloud.
Yep, that's it.
Wow, that's pretty amazing. We've gone from building a simple Docker image to deploying it on AWS in just a few steps. So far, we've mostly been talking about single container applications, but what happens when we want to deploy something more complex, like an app that has multiple components, each running in its own container?
That's where things get really interesting. And to demonstrate this, the guide introduces a multi-container app example. It's an app that tracks food trucks in San Francisco.
Food trucks and Docker, what a combo. I'm already intrigued.
This example uses a Flask backend for the main application logic and Elasticsearch for searching through the food truck data. So now we're dealing with multiple containers that need to communicate with each other.
I see the challenge. It's like having different parts of the app scattered across different food trucks, and we need to find a way to coordinate and share info between them. How does Docker handle this?
That's where Docker networks come into play. Docker provides several network drivers, and the guide focuses on the bridge network. Think of it like creating a dedicated network specifically for our containers, allowing them to communicate with each other while also keeping them isolated from the outside world.
So it's like creating a private radio channel for our food trucks to communicate on, no outside interference, just smooth communication between the different parts of our app.
Exactly. And we can even create our own custom networks and give them names, which makes it easier to manage and understand how our containers are interconnected. The guide walks through creating a network called Food Trucks Net and then launching both the Elasticsearch and Flask containers within this network.
That's cool, but managing multiple containers, networks, and configurations can get complicated pretty quickly. Is there an easier way to orchestrate all of this?
There is. Docker provides a tool called Docker Compose that simplifies the process of defining and running multi-container applications. So instead of launching each container individually and manually configuring networks, we can use Docker Compose to define the entire app stack in a single file called dockercompose.yml.
Ah, so it's like having a conductor for our multi-container orchestra.
Precisely. This dockercompose.yl file describes all the services, networks, and configurations for our application. Then we can use a single command, docker compose up, to bring the entire application up, including all the containers, networks, and their connections.
This is sounding really powerful now. We can define our entire multi-container app in a single file and launch it with one command. What else can Docker Compose do?
It's also super useful for development workflows. Imagine you're working on your Flask backend, and you make some changes to the code. Instead of having to rebuild the entire image and restart the container every time you make a change, Docker Compose lets you mount your local code directory as a volume inside the container.
A volume. What does that mean?
It basically means that any changes you make to your code on your local machine will instantly be reflected inside the running container. It's like having a live synchronized connection between your code editor and the application running inside the container.
That sounds incredibly efficient, so I can make changes to my code, hit save, and instantly see those changes reflected in my running application.
Exactly. And to make things even better, a lot of web frameworks like Flask offer a debug mode that automatically reloads the application whenever the code changes. We can enable this debug mode in our dockercompose.yl file, so any code changes will instantly be reflected in the running application.
This is truly amazing. Docker Compose not only simplifies the management of multi-container apps, but it also streamlines the development process. But we deployed our single container cat GIF app to AWS using Elastic Beanstalk. What about our multi-container food truck app?
Well, for more complex multi-container applications, AWS offers a more flexible service called Elastic Container Service, or ECS for short.
So we've got Beanstalk for single container apps and ECS for multi-container ones. What's the main difference between the two, and how do we deploy our food truck app to ECS?
Those are great questions, and we'll dive into all those details in the next part of our deep dive.
Stay tuned. All right, so last time we were talking about this cool food truck app.
Yeah, the one that uses Flask and Elasticsearch.
Right, and we touched on Docker Compose, which makes it easier to manage multiple containers locally. But the big question is, how do we actually get this app running in the cloud?
Good point. Well, for more complex multi-container apps, AWS has this service called Elastic Container Service.
ECS?
Yeah, ECS. It gives you a lot more control and flexibility compared to Elastic Beanstalk, which we talked about earlier.
Okay, so it's like Beanstalk is good for simpler deployments, but ECS is where it's at for more complex stuff.
Exactly. It's like a playground for your Docker containers. You can define resources, set up networking, and manage how containers interact all within AWS.
Sounds powerful, but also maybe a little intimidating. How do we even get started with deploying to ECS?
It's actually not as bad as you might think. ECS has a command line tool that works really well with Docker Compose.
Oh, that's good to hear.
Yeah, so we can take our existing docker compose.ynl file, make a few adjustments, and then deploy it to ECS.
So we don't have to start from scratch.
Yep, we can leverage what we've already done.
That's a relief. But before we get to the actual deployment, what are some of the key differences between running our app locally with Docker Compose and deploying it to ECS? Like, what kind of adjustments do we need to make?
One big difference is resource allocation. Locally, Docker Compose can just use your machine's resources, but in the cloud, we need to be more specific about things like memory limits and CBU shares for each container.
Makes sense. We don't want our app hogging all the resources on a shared server.
Exactly.
So we need to tell ECS how much memory and processing power each container is allowed to use.
Yep. And another important thing is logging locally. Docker Compose might just output logs to your terminal, but in ECS, we want to configure logging to AWS CloudWatch.
CloudWatch.
Yeah, it's a service that provides centralized log management and monitoring.
Oh, so it's like a central dashboard where we can see logs from all our containers.
Yeah, and we can get insights into our application's performance.
Okay, that makes sense. Are there any special considerations for logging with our food truck app?
Well, Elasticsearch can be a bit resource intensive, especially when it's dealing with a lot of data. So we need to make sure we give the Elasticsearch container enough memory and configure logging properly so we can keep an eye on its performance in CloudWatch.
Gotcha, memory and logging check. What about the Docker images themselves? Do we need to do anything special with them before deploying to ECS?
Yes, definitely. We need to push our custom food trucks web image to Docker Hub so it's accessible from our ECS cluster.
So it's like uploading our app's blueprint to a central location so ECS can grab it.
Exactly.
Okay, so our image is on Docker Hub. Our docker compose.yml file is updated. Are we ready to deploy?
Almost. We still need to install and configure the ECS command line interface.
The ECS CLI.
Yep. The guide has instructions for doing this. It involves setting up an AWS profile with your credentials.
Okay, so we need our AWS access keys.
Right, you can get those from the AWS console. The guide also links to the official ECS docs if you need more detailed instructions.
Awesome. Once the CLI is configured, are we good to go?
We are. We use the xclip compose up command, and that's it.
Seriously, just one command.
Pretty much, yeah. That command will take our modified docker compose.yl file, create all the necessary infrastructure on AWS, and deploy our app.
It's amazing how much automation is built into Docker and AWS. We're basically defining our entire app and infrastructure in code, and then one command takes care of everything.
It's pretty slick. So what happens after we run this command? How do we know if our app is actually up and running?
Yeah, good question.
You should see a message in your terminal that says your containers are running. You can also use the xclip command to list the running tasks in your ECS cluster.
Okay.
And that will show you the public IP address and port you can use to access your app.
So we can just point our browser to that IP address and port and see our food truck app live in action.
Yep, exactly. And if you want a more visual overview, you can always check out the AWS ECS console. It's like a control panel for your ECS cluster.
Sounds handy. I'll have to check that out. But before we move on, the guide mentions something about cleaning up our resources.
Oh yeah, that's important. We don't want to leave our containers running and racking up charges on AWS.
Right. Good point.
The xcli downforce command will take care of that. It will deprovision our cluster and all the associated resources.
Okay, so we deploy with xcli compose up and clean up with xcli downforce. Got it. So we've covered how to deploy our food truck app to ECS, and we even touched on the ECS console. But there's still one aspect of Docker Compose that we haven't really explored yet, how it can improve our development workflow. Oh yeah, we talked about how Docker Compose makes it easier to define and run multi-container apps, but it can also streamline the development process itself, right?
Exactly. Remember how we talked about mounting our local code directory as a volume inside a container? Well, that's not just useful for deployments, it's also super helpful for development.
Right, because it means any changes we make to our code locally are instantly reflected inside the container.
Yep, no need to rebuild the image or restart the container.
So it's like having a live connection between our code editor and the app running in the container.
Exactly. Imagine you're adding a new feature to your food truck app. You make some changes to the code, hit save, and boom, those changes are immediately visible in your running app.
That's got to be a huge time saver, especially when you're making frequent code changes.
It is. And to make things even better, a lot of web frameworks like Flask have this debug mode that automatically reloads the app whenever the code changes.
Oh yeah, I've used that before. It's really convenient.
Yeah, so we can enable debug mode in our docker compose.yl file and get instant feedback on our code changes.
That's awesome. So we're talking about volume mounting and debug mode. What a powerful combo for development.
For sure. It really changes the way you work with containers.
It sounds like Docker Compose is more than just a deployment tool. It's a key part of the whole development process.
Absolutely. It can really streamline your workflow. But, Docker can be a bit daunting for beginners. There's a lot to learn, and it can feel overwhelming at times.
Yeah, for sure. But that's why resources like this guide are so valuable. They break down complex concepts into easy to understand steps.
Exactly. And there's a ton of information available online, too, so don't be afraid to dive in and experiment.
That's what we're all about here on the Neep Dive, helping you explore new technologies and figure out how to use them.
And we've only scratched the surface of what Docker can do.
Yeah, there's so much more to learn.
But hopefully this has given you a good foundation and made you curious to explore further.
Speaking of exploring further in the next part, we're going to step back and look at the big picture, why Docker has become so popular and what its future might hold. Stay tuned. All right, so we spent the last couple of deep dives getting our hands dirty with Docker, learning how to build, run, and even deploy apps using containers.
Lots of hands-on stuff.
Exactly, but now I kind of want to step back and look at the bigger picture, like why has Docker become such a big deal?
Yeah, that's all the fuss about.
Right, it's everywhere you turn these days. So what's the secret sauce?
Well, I think it comes down to solving a really fundamental problem in software development.
Okay, which is?
Consistency.
Oh, consistency.
Before Docker, getting an application to run the same way across different environments was like,
A nightmare.
yeah, it was a huge pain. It worked on your machine, but then it would break on the test server and forget about production.
Oh, yeah, the classic, it works on my machine excuse.
Exactly. And Docker just eliminates that whole problem. It provides this consistent, reliable way to package and run apps so they behave the same way no matter where they're deployed.
Whether it's your laptop, a testing environment, or some massive server farm.
Exactly. It's a game changer for developers.
So no more scrambling to figure out why an app works in one place but not another.
Nope. Docker takes care of all that.
That's got to be a huge relief. But it sounds like Docker's benefits go beyond just making developers happy. What about the impact on organizations, like from a business perspective?
Oh yeah, Docker brings some serious efficiency to the table.
How so?
Well, containers are lightweight, and they share the host operating system's kernel, which means they use fewer resources compared to virtual machines.
So we're talking about lower costs.
Definitely lower infrastructure costs, faster deployment times. It's a win-win.
Music to any business leader's ears, saving time and money. Any other benefits we should mention?
Well, Docker also promotes a more agile and collaborative development process.
Okay, I thought so.
Teams can work on different parts of an app independently, using containers to manage dependencies and ensure everyone's working with the same environment.
So it's like each team has its own little sandbox to play in, but everything still works together seamlessly in the end.
Exactly, and that leads to faster development cycles and more frequent releases.
Which is crucial in today's fast-paced tech world.
Absolutely. Organizations need to be able to adapt quickly, and Docker gives them the tools to do that.
So it's a win for developers, a win for businesses, and ultimately a win for users who get better software faster.
That's the idea.
It's amazing how much Docker has changed the game. But what about the future? Where do you see Docker going from here?
Oh man, the future of Docker is wide open. We're already seeing it being used beyond just traditional app development.
Really? Like where?
It's gaining traction in areas like data science, machine learning, even serverless computing.
Serverless computing, that's another one of those buzzwords I keep hearing, but I'm not entirely sure I understand it. How does Docker fit into that world?
Serverless computing is all about abstracting away the infrastructure so developers can just focus on writing code.
So no more worrying about servers or scaling or any of that stuff.
Exactly. And containers, with their portability and self-contained nature, they're a perfect fit for serverless.
So developers can just package their code into containers, and the serverless platform handles the rest.
Yep, it's a pretty powerful concept.
It sounds like a pretty big shift in how we think about building and running software.
It is. And as containerization and serverless computing continue to evolve, we can expect even more innovation in this space.
Exciting times for sure. But even if you're not a developer, understanding the impact of Docker and containers is becoming more and more important.
Definitely. It's affecting everything from how software is created to how it's delivered and used.
Well, it's clear that Docker isn't just a fad. It's a fundamental shift in how we approach software development. And thanks to resources like Prakar's Guide, anyone can start exploring this world.
Absolutely. It's more accessible than ever before.
So we encourage you to dive in, experiment, and see how Docker can change the way you work with technology.
Who knows, maybe you'll build the next big thing.
And on that note, we've reached the end of our deep dive into Docker. Hopefully you found it insightful and are now ready to embrace the power of containers.
It's been a fun journey.
Yeah, it has. And remember, the world of tech is always changing. So keep learning, keep exploring, and we'll see you on the next deep dive.
1825.
Yeah.